Good morning, student. In previous class we have discussed about distance and time graph. Today I will discuss about velocity and time graph. So let us start it. First, since we are going for straight line motion case, so for a straight line motion, let me write that for a straight line motion, the distance will be equal to displacement, and similarly we can say that the speed will be equal to velocity. So this is true only for a body moving in straight line motion. So now I will go for two graphs. One is for uniform motion case and another one is for uniform acceleration case. One is for uniform motion and the second one is for uniform acceleration. So in case of uniform motion, we know that the body moves with constant velocity. So for uniform motion, the body moves with constant velocity. That means there is no change in velocity. Then what will be the graph? The graph will be obviously a straight line passing, a straight line which is parallel to the time axis. As I had already discussed that the time axis is taken along x-axis and the other one along y-axis. So this one will be my velocity, and let the velocity in meter per second and the time t in seconds. So what will be the nature of graph? Now see, with respect to time, as time passes, suppose this is 10 second, 20 second, 30 second, 40 second. As time passes, the velocity remains constant. Suppose at 10 second it is having 40 meter per second velocity. Then with the passage of time, since there is no change in velocity, so for each time the velocity will remain 40 meter per second. So what will be the nature of the graph? The nature will be a straight line which is parallel to time axis. So what I will write for the nature of velocity time graph for uniform motion? Now it is a straight line parallel to time axis. Now let us draw the graph for uniform acceleration. Uniform acceleration means the velocity will increase equally in equal intervals of time. So since it is increasing equally in equal intervals of time, means if the time is 10 second, 20 second, 30 second, then the increase in velocity will also follow the same pattern. Suppose it is 10 meter per second, 20 meter per second, 30 meter per second. That means at 10 second the velocity will be 10 meter per second. At 20 it will again increase in equal intervals of time, equal increase in its velocity. So 20 second, 20 meter per second. In 30 second the velocity will be again 30 meter per second. So now the nature will be a straight line passing through origin. So as we know, in case of uniform acceleration, the velocity will increase with equal intervals of time. So what will be the nature? The nature is a straight line passing through origin. uniform acceleration, that means acceleration will remain constant. When acceleration will remain constant, when velocity will increase equally in equal intervals of time. So these are the two cases which are in our course. So from this graph we can find out some parameters. What? Let us try to find out the area under this graph. So within 40 seconds the area covered by this graph is, I can write A, B, C, D. So what is the area under V versus T graph? Area under V versus T graph. So here you can see that the area under this graph is A, B, C, D. So area under V versus T graph, I can write it as area of A, B, C, D. So then what will be area of A, B, C, D? Since it is a rectangle, so I can write area of A, B, C, D is equals to length into breadth. So length is how much? No, AD, and breadth is, I can write AB. So what kind of physical quantity is given by AD? Here you can see that AD will give you a time parameter. 40 second minus 0 second. Obviously it is a time value. So in place of AD, I can write as time. And AB, what is AB? AB value means y-axis value, and y-axis value is our velocity. So time into velocity. Since we are going for a straight line motion, I can write it as time into speed. And what is time into speed? We know speed is equals to distance by time. So distance will be equals to speed into time. So time into speed will give us distance. So what we can conclude, that area under velocity time graph will give us distance. Area under VT graph will give us distance. This expression, that is area under VT graph is a distance, is also valid for this uniform acceleration graph. Next, for other cases, the graph will not be like this. It can be different for different types of motion. So with this, I will conclude that area under VT graph will give us distance. So go through this and its numericals. Next class we will discuss about equation of motion. Thank you, students.